Okay, so let's get started here. My name is Alex Marcy. I'm the president of Corso Systems. The reason we're doing this webinar is we've gotten a lot of calls in the past few months about MES systems and implementations. And during each of these meetings, we're spending a lot of time doing some education about what an MES system is and how to get some value out of it. And it's a big investment of time and resources, and it can be a paradigm shift for a manufacturing company. So we're really looking to help educate our customers on the right way to do things and understand all of the variables and all the different systems out there and how they can best leverage them at their facility. So we distilled out a lot of our typical conversations into this webinar, and we decided to put it on to get a larger audience in one go, to take a look at MES systems as a whole and understand the value and the ROI they can provide. So it's just the essentials of MES and how you can leverage data and information to empower your business. First, a little bit about us. We're a system integration firm based out of Chicago, Illinois. We've been in business for about a year. I've been working in the integration world for about 10 years and working in MES systems primarily for the last 5 or 6 years. Over the course of my career, I've worked with pretty much every major system out there, in no particular order. Inductive automation, Wonderware, Rockwell, Siemens. We've done some Plex and ClickView work. We've worked with most of the major ERP vendors out there. Some of our customers have IFS, a lot have SAP, and we've seen some Microsoft Dynamics as well. And on the database side, we've dealt with Oracle and SQL Server quite a bit, as well as MySQL and some other open source options. And then for our customized web interfaces, we've done a lot of .NET development and Ruby on Rails as well. So that's kind of an overview of the systems we've worked with. These are the major ones most people are familiar with. We've worked with some other smaller things, as well as developed completely custom solutions for some smaller systems. But we don't shy away from any systems that are out there. If somebody has something new or is looking at something else that we haven't seen before, we're happy to do our research and understand their offering, go in and get any training or whatnot, and really understand the value that can provide and how it fits into our customers' ecosystems. Some of our customers, we've done MES and information systems before. These are what we have listed on our website that we can talk about. Jackson Energy is an oil refining company. EP Minerals is an aggregate processing company. And we've done quite a bit of work with them, all the way from their ERP all the way down to their plant floor, integrating a bunch of different business systems. Locus Energy is a solar company we're doing a lot of data collection systems with. And SunOpta Foods is a company we're working with on some of their facilities, integrating their OEM equipment into their MES systems.
I'm Mike. I'm also with Corso Systems, and what I'm going to do is just go through a high-level overview of what an MES system is and what it will give you when you implement one. And then after that, Alex will drill down a little bit on the specifics of how to calculate OEE, some KPIs, some real-world examples of what the systems will look like when they're implemented. So for the basic MES system, everybody's process generates data, and that data will then get aggregated into an MES system, where that data is turned into information that you can use, and that information then gets pushed to everyone who needs it, who needs different parts of the information. And then once everybody has better information, everyone is able to make smarter decisions for their area of responsibility, and then in turn the business as a whole becomes more efficient. So some basic benefits is less downtime. So with a better understanding of your process, you can figure out how far you can push a machine, how often that might need maintenance, and you can do preventative care so that you can get the most out of that system or that process or that machine without running into bottlenecks and running into maintenance issues and having unplanned downtime. You can have increased productivity, so you can anticipate the bottlenecks before they become a problem, before they become an issue. This is big in any manufacturing environment, knowing minimizing your unplanned downtime, maximizing your scheduled production, and higher efficiency as far as using your data to adjust your operations in every part of your plant, making all of your machines and all of your systems work together. And once you have those working together, you have full integration. And MES is really about getting data from the bottom floor of your operation all the way to the top, so that everybody in the organization, in the business, has access to the best data they can, the best information, and then can in turn make the best decisions for the business as a whole. So this is the information flow, just a basic shop floor to top floor example, where we're looking at the process equipment on the very bottom. These are your PLCs, your instrumentation in the field, your bottling lines, things like that that are generating data. All of that data gets pushed to the MES layer, which is essentially the brains of your operation. It's going to do things like keep things in databases. It's going to help you analyze and work with the data, and then that data will eventually get pushed back up so you can integrate into your ERP system, where it integrates into your shipping and receiving, order fulfillment, your financial systems, so that everybody has access to the right information. And so what we're getting at here is your data really does tell your story. It is kind of the heartbeat of your operation, and if you use the data in the right way, you can figure out more about your process than you knew before. You can look at things like your OEE calculations, your availability, your on-time orders, and you can start to trend that data over time and figure out what things are working for your operation, what things are not, how to get a better gauge on what you should be doing to boost your efficiency as much as possible. And with that comes remote access. All of the vendors that we work with, every solution that we've seen has the ability to implement remote access. And this is really big now because everybody wants to have the access to the data. And some real world examples, like we've worked with an oil refinery who the plant managers wanted to have access to the data in real time. So let's say an operator has an issue or doesn't know how to handle a specific problem, someone can just pull up their tablet, look at it, and say, okay, here's how we should handle the situation better. There's also report generating capabilities. So maybe every morning at 9 o'clock, someone wants a report of what does the OEE look like, what does the TDP look like, what is all these things, where our calculations at, and they can get these reports pushed straight to their phone, SMS, email, whatever is most convenient for them, so that everybody has a loop inside of how the business is doing as a whole.
Okay, and one note, if anybody has any questions throughout the presentation, feel free to enter those in the chat and we'll take care of those at the end. So when we typically go into a new customer looking to implement MES, a lot of times they're kind of looking to get everything they can out of it at the initial outset. And, sometimes we have to go in and really help them set expectations about the best way to implement a system and how to overcome, some of the common obstacles that we see. Typically, we find some of the hurdles are when you're implementing an MES system, you're adding a new level of monitoring to your system that maybe your operators aren't used to, and that can lead to some issues where people feel like you're tracking what I'm doing now, and you haven't necessarily been tracking that before. You're going to bring the hammer down on me for some reason, or really understand the soft skills component of it, how the operators are going to interface with the system and feel about it. So that's part of the education, is educating the entire company about why the system is being implemented and how it's going to be used. Then once you have an implementation, you have to understand what your workflow adaptations are. How do we need to enter data differently, or change some of our internal processes to get information into or out of the MES system and use that to actually make decisions. And we've also found that starting with a small system or a small implementation of the eventual overall system is a better way than starting with the entire system up front. So let's say you have 4 processing lines at your facility. If we would go in and implement MES on one line to start with, to get everybody used to the system, get used to tracking OEE, and how the actual information is going to be used. And then you get everybody used to it, then expand out to the other lines. Or if you have multiple facilities, start with one plant and start small and then expand from there. And we find that that's really helpful because as people get used to using the system, they'll find ways that they want to use it, information they need, that you may not have found if you did an entire rollout up front. So we find that just starting small is the best way to do it, and then grow from there and kind of snowball the system. And then that also helps facilitate continuous improvement, rather than giving you a dump truck full of information that you need to sort through. You can really start understanding your OEE, your downtime, your productivity, and how you can improve that. And then as you get more information, you can go back and check that against how you think your system should be operating, and really get into a continuous improvement cycle from there, which is what MES is really, the goal is enabling continuous improvement. So typically the first component of MES that anyone looks at is OEE, which is overall equipment effectiveness. We like to think of OEE as an iceberg, where the tip of the iceberg is the actual OEE value, which is just one number that demonstrates the health of your plant. OEE is made up of three components: quality, performance, and availability. Quality is how many finished goods you're producing that you can sell versus how many total goods you're producing, including your rejects. Performance is how many goods you're producing during a shift, your cycle time, versus your designed cycle time. And availability is your actual uptime versus your total planned uptime. So some of the breakdown of what we see, quality is going to be goods that have failed QA testing, rework, and scrap, that are lost things that you've already created. Performance, you're going to have minor stops throughout the day, bottlenecks or speed loss on some of your equipment for various reasons. And availability would be any sort of unplanned downtime. Could even be scheduling if you're market constrained instead of capacity constrained, and you're not running your plant 24/7. That could impact your OEE depending on how you define it. And you may run into utility issues like power outages that prevent you from running. And sort of an umbrella over all of these three components are more global things like operator error, general process upsets that may be things that you're not expecting, or it could even be things like supply chain management if you're having trouble getting inventory, or you don't have enough warehouse space to store things that you've created to send out. That could kind of get into more of lean manufacturing capabilities, sort of like the Toyota model of having the inventory on the line exactly when you need it and only having enough in storage to produce what you need at any given time. So that's sort of an overview of OEE, and typically the things that we would see that affect it. So how do we calculate OEE? So here on the left, we'll see we have our total production time, including our planned production time with planned shutdown. So this would be for a plant that's not running 24/7. For our total production time, we're going to have a net operating or a total operating time, and then we're going to have unplanned downtime, which decreases our availability. Then with our net operating time, we're going to have speed losses or cycle time impacts or bottlenecks that affect our performance. Then within our net operating time, we're going to have a total amount of production time that's productive, and then production time that we're actually just investing into lost product that affects our quality. So if we multiply the availability times the performance by the quality, we get the overall OEE value. And here we just see availability, is your process uptime over your planned production time. Performance is your cycle time over your ideal cycle time per product produced. Your quality is your good pieces produced divided by your total, and OEE is just a multiplication of all of those. And a lot of times, OEE is presented in a gauge format in a dashboard. So that's an example of something you might typically see. And depending on the package, you can color code things to make it easy to see, is our availability good, our quality is doing okay, and our OEE is doing good or bad, depending on the color. The thing OEE doesn't tell you directly is how all of these are affecting your bottom line. So one thing that we talk about with some of our customers is adding another layer of information to OEE to really understand what's the ROI on an MES system, and how can we easily correlate that to something they may be familiar with in OEE. And we find that talking about the cost per minute of downtime is a pretty good gauge of that. If they don't understand what a minute of downtime costs or an hour of downtime for their plant, helping them understand all of the different components that go into that is usually the first step of understanding how can you see a bottom line impact from your MES system. So we basically would take the total cost of downtime, the reduced margins that we're seeing if we're not producing enough parts per shift, and then the costs that are incurred in producing goods that are lost to quality issues. We can basically add all those up and understand the total cost of lost production. And again, these things may be affected by product code. So product A may cost a different amount than product B to produce. So as we grow the system and the information that we have available, we can really drill down into any level of detail we need to understand what are our overall costs in production and how can we improve those and reduce the costs and improve the profits. So that's another layer that we would use like an ERP system to get that information from and add value to the MES system and really tie in the production level people with the business side people, because an operator is going to look at things differently than a vice president of operations will, and different than a plant manager will. So really an MES system's power is giving the operators information in the format they need to see, giving the plant manager information in the format they need to see, and the CEO information in a different format entirely that is really geared towards their specific needs. So how do we go about improving OEE? First, the obvious first step is we need to start tracking our downtime, our performance, and our quality. We're going to go through just a downtime example here to show you the math a little bit. The same thing would apply to quality or performance. The common tool that we see is used is a Pareto analysis. What this is you take all of your downtime reasons for a particular time period, say a particular shift or a production run, and you take stock of either the number of occurrences or the duration of downtime events for each different reason code. So let's say your plant goes down because of mechanical issues, or it's planned downtime, or you have power failures or electrical issues. Each one of those would be given a specific reason code so that you can understand beyond an overall view of we had 10 hours of downtime this month, what made up that 10 hours of downtime. And using that and then sorting that in a descending order here allows us to see that in this particular graph, plug ups and mechanical were the top two downtime contributors. So on a Pareto chart, we have the bar graph, and then this line represents the percentage of each of these bars that they contribute to the entire downtime. So if we take a line here for plug ups and mechanical, we see where close to 50% of our downtime is attributed just to those two reasons. So if we were to then go in and find a way to reduce those, we could reduce our overall downtime and affect our availability quite a bit, thus affecting our overall OEE. And again, if we do the same thing for performance or quality, you can understand your top contributors and the effect fixing those will have overall. So let's say for our example that we have 250 minutes of planned production on a production run. And after that production run, we had 45 minutes of downtime, as shown here based on the downtime reasons, which gave us an overall availability of 82%. So let's say, now that we know that, we worked with maintenance and they went in and fixed the mechanical and plug up issues. And as we'll see here on the chart, mechanical went down from 15 to 5, and then plug ups went from 8 all the way down to 1 here on the right. So let's say that we fixed those and we ran another production run, and now we only have 27 minutes of downtime because we improved those downtime reasons, which gives us now 89.2% availability. So we increased our overall availability from 82 to 89.2, and assuming quality and performance stay the same, we would then increase our OEE about 5%. So the trick there would be understanding, not only are we going to reduce the overall downtime, but what is the cost to reduce a specific reason code? And do we need to buy a new piece of equipment, or can we just go change some filters? And then from there, you can understand, based on the cost of downtime, based on your downtime per minute cost, we can understand, if it took us $1,000 to improve our availability by 7%, what does that cost? Let's say that that's a $2,000 increase. So you can really understand what your costs and your benefits are, and from there you could put some assumptions in and say, if the MES system helps us improve our uptime by 10%, that has a direct correlation to our overall costs and profits. So that's how we would typically work with a customer to understand their ROI is the cost of improving their productivity versus what they're going to see at the end result of that. Another common thing that we start out with, after looking at OEE, is talking about a real-time cost per unit. This is essentially another KPI, a key performance indicator, like OEE, that allows someone to understand their costs to produce a good over the life of the plant. So the cost per unit would take into account things like labor, your operators, janitorial crews, overhead staff, whatnot, your raw materials to produce a good, the energy you need to use, inventory you have to have on hand, and your delivery costs. Basically, the entire life cycle of the product, you could incorporate those costs, depending on how you want to define it, to really understand what it costs to produce any particular good in your plant. One example of this is, IKEA, the furniture company. They figured out a way to automate their production and packing lines to where there's no operators involved, so they can shut off the lights. So they don't really need to worry as much about the energy costs compared to someone who has a bunch of operators that need the lights to be on. That's kind of an extreme example. A lot of companies probably can't deal with something like that based on specific processes, but it's one example of where you can really understand what's our energy cost, or what are our raw material costs going into this good, and how can we reduce those. And the power of this would be if you were to track over the course of different shifts or different parts of the year, what's our real-time cost per unit during any time period, and drill down into that to see maybe it costs us more to produce things during the summer because electricity is more expensive, or our raw materials fluctuate, or if you're an electronics manufacturer, the price of gold changes your raw material costs. So you could really understand over the life of your plant and your process, what's our cost, and are there ways to reduce it, or is it going up, and are we aware of that? And that's where the MES system really comes into play, is not only understanding those costs, but even being aware of how they're trending. Because some people that we talk to, especially who don't understand what their downtime costs are, may not understand, over the course of the year, our costs fluctuate quite a bit. And from there, you could maybe plan production a little bit differently to reduce those costs overall. But it's all about having these KPIs that you can use to give you an easy way to understand the health of your plant, with the ability to drill down into the numbers that make up the KPI. And that's where we also talk about, starting small. Is some people expect an MES system to really be the silver bullet that fixes all of their problems, and it's really not. What an MES system is an informational tool you can use to prioritize and understand what work you can do and what effect that work will have on your process. So just like with OEE, it's understanding what is our major cause of downtime, and you still have to do the work to fix that, but it helps you understand what should we fix first or second, and prioritize based on whatever is important to you, whether that's cost or reducing downtime, or whatever it is in your particular case. It's not, you still have to go in and do the work. It just helps you understand what work you need to do. The final level of MES systems, as an overall view, is enterprise integration. So this is where we're really going to integrate the shop floor, the plant floor, up to the top floor, integrating the process and the business side. This would be things like taking into account, customer ordering, quality control, production scheduling, your raw materials inventory, and even your shipping and receiving schedules and costs. So we can basically, as we saw previously in the slides, we could take all of that data from the business side and integrate that into the process side. So what does that mean? One example that we've done in the past was for a slot machine manufacturing company, and they had 50 different product codes that they were producing on on 10 different lines in their facility, and they all had different cabinets for their slot machines and different components and computers and screens and buttons and everything that went inside the slot machines. So they had the raw material was the empty cabinet starting on the line. And as it went down the line, it would pass an RFID reader. And there was an RFID chip installed on the pallet that each slot machine was on. And in their ERP system, based on their customer requests and orders, they would tie the different RFID chip IDs to a serial number on the cabinet with a barcode. And as it passed over the RFID reader, after an operator would request, in their workstation, they needed a new machine to work on, it would go back. The RFID number would go back to the database through the MES system and go to the ERP system and say, do I have enough inventory to ship this line to the next available operator? And if they do, then it goes to where it needs to go, and the operator does what they need to do, and then they send it on down the line. But let's say they didn't have enough screens in place in inventory to complete that machine, then it would send that machine down to a rework area or storage until they received the inventory. And then there were some other systems in place that would alert operators to go back to that area to get their machines. But it basically helped the operators avoid bringing a machine into their station that they couldn't actually complete because they didn't have enough inventory. And that would save a lot of time because it took time for the machine to come down the line, go into their workstation, and then for them to get all the parts they need and then send it back out. If you can avoid a couple of those steps and send a different machine that they do have inventory for, that's really one of the ways you can integrate your ERP data and your inventory down to your plant floor. The other way that we typically see it is with production scheduling. Along with the OEE availability calculation, we can really get into the ERP level and say, here's what we need to produce this particular day, these particular product codes, and have the MES system automatically populate your production scheduling, your recipe management, if necessary, in the control system, and automatically define your planned production time and what product codes that's associated with, and then automatically calculate all of your OEE values without having to really go in and do any data entry or whatnot. And enterprise integration is almost limitless what you can really do with it. We've also done things like build management of change systems for process change management, or you can do things like product lifecycle management or track and trace to track your raw materials coming into the plant as they're going through your process and then as they're shipped out to the customers. It's really, once you have the conversation and you understand the possibilities and things that other companies have done, you could really go as deep as you want to here. Again, start small and understand the value and the costs associated with those integrations. But this is where the power of MES really comes in, well beyond just a process historian tracking your data from your process or a SCADA system for the operators to control it. It's really taking that data from your process equipment and your control system and turning it into information that the business side can use to make decisions. The other component of MES is not only having the information, but getting that information out to the people who need to see it. Commonly, this is done with reporting. This can either be something you access on your phone or your tablet, or through a web interface, or a PDF file that gets emailed out. Reports are typically, you'd have a production report, an OEE report, maybe a downtime report, or quality, really depending on who's going to be reading this report and what they want to do with it. The power of reports is with parameters. So you can say, we're going to have a template downtime report for a particular line, and we're going to develop that once. And then if you add another line or you expand your MES system to 3 or 4 lines at your facility, then you don't have to go through and build a new report each time. You could simply say, okay, I want to pull up the downtime report and run it for line 1, or I want to pull up the downtime report and run it for line 2. And the MES system goes and grabs the data from the database and populates the report. So you can really streamline some of the development time that you may otherwise have to do by hand, or if you're doing something in Excel, can be more time consuming. We can also do the same reports with different time periods as parameters, so for shifts or production runs. And there's really a lot of different ways to access reports. Most systems out there have some sort of a web interface. You can log in with a browser, email notifications, so you can send out a PDF report or an email template to somebody on a schedule. If operators are using this information, you can typically include it in your operator interface in your HMI and control system. Or you could even send it out to a file system, so the reports get stored somewhere on a server. It's really dependent on who's using the reports and how they want to use them. The other component similar to reports would be dashboards, which would be typically a web interface with fancy graphics and gauges and different charts and whatnot. That you could even put up on a screen on the plant floor to show operators, what's our OEE and what's our top downtime causes this shift and whatnot. And again, reports can be sent out on scheduled basis, or you can configure reports to be sent out based on, say, alarm conditions in your plant. If the plant goes down, generate a report and send it out, or send out a report every day at midnight. There's lots of options there. We pretty much covered OEE and some of the possible integrations. Out of the scope of this webinar would be things like statistical process control and track and traceability. Statistical process control is where you're bringing your quality systems in line with your process data through the MES system, so you can understand how your process conditions directly affect your quality output. Track and traceability is tracking a product genealogy from a raw material input into the process to finished goods coming out. Other things are energy monitoring, so integrating with your power meters, or if you have a steam system, to really calculate those real-time costs of your energy or your energy usage. Something that was going around in the web a while ago was New Belgium Brewing built a energy recovery system and are running on a solar plant. And part of the way that they did that was through implementing MES to really monitor their energy usage and understand where those energy sources were coming from and find ways to reduce their load on non-renewable fuels and move towards a renewable situation. Another system is like computerized maintenance management systems. You can use for predictive maintenance, runtime-based maintenance instead of schedule-based maintenance. Other things you can do are customer resource management or CRM integrations, and those can be helpful for things like product complaints. If you, depending on your culture at your company, if you want to have operators be aware of product complaints directly in the system based on a lot number, that would be one option, or along with like track and traceability, that could even be tied in with recalls if you have to do a product recall. Another item that's available that we're starting to see some adoption of is like human resource management. So this can either be integrating some training documentation into the MES system so that operators can really have a workflow or a procedure on hand if they need one. Or, and this is probably maybe a little scary for the operator, you can also, just the same way that you're looking at downtime based on a product code or per shift, you can look at your KPIs in terms of operators and understand, does a certain operator excel at their job, or are you having consistent downtime with say a new operator who hasn't properly been trained and you're not aware of that fact yet. You can really use an MES system to figure that out and understand where your training resources are being best utilized and where you need to invest a little bit more. Again, that's maybe a little scary for some people to think about things that way. And as we mentioned, production scheduling to really get data automatically from your ERP system into the plant floor and your control system. That's another, these are pretty much in order of the next steps beyond OEE that we would typically see. And again, some companies will come in and pick and choose from this list. Maybe they'll start with an energy monitoring system and then bring in the rest of the MES after that, or start with a maintenance system. It's really, what needs are you trying to address as an end user, and what systems do you need in place to handle that? So that wraps up our portion of the presentation. I think that pretty much covers everything we wanted to talk about as far as an introduction. We're going to take questions now, and if anybody has any follow-up, you can email us, Mike at Corso Systems or Alex at Corso Systems, or take a look at our website, as you've probably seen from signing up for this. So I'm going to pull up the questions here just a second. Okay, so Christian Vieira asked, as we work with MES vendors, what is the main technical criteria to select the best solution? No, it's not an easy question, but thoughts on how to filter only the best solutions. Okay. So that's a big umbrella to cover. That's pretty much why people bring us in to talk to them. As far as the technical criteria, one of the main criteria that we look at is if they have something in place already. If they're using a Wonderware solution or a Rockwell currently for their control system, it may make sense to bring in a Rockwell or a Wonderware solution because they already have some support costs that they're already paying. If you were to go to a different company, that may change that. So typically that would be one of the first questions we ask. This one is not technical, but it would also be, does the customer have any sort of preference for a particular system? Because if somebody says, I really want to work with inductive automation, and we're coming in and we're saying, here's a Siemens solution, they're going to look at us like we're idiots. So if we really kind of understand if they have a preference, I know that's not a technical one at all, but that has influenced a lot of decisions that we've seen made along the way, for better or worse. The other questions that we ask is really what they're looking to get out of the system. If all they want is an OEE system to track downtime, that may filter out some of the more expensive solutions that offer statistical process control and energy monitoring. The other question that we would ask is, what is their overall system architecture, as far as, is this a standalone facility, or do they have multiple facilities all around the country or all around the world? We can filter out some systems based on the specific architectures there. Some of the systems are easier to integrate multiple facilities into one interface, and others are not. The other question that we would also have is, um, along the lines of their existing infrastructure, is what sort of ERP system are they using? Um, and what is the cost associated to integrate with that? Basically, if they have an Oracle system instead of a SQL Server based system, there's going to be some additional costs to integrate some of the SQL Server based MES solutions into that ERP system. Or vice versa, if they have SQL Server and we're bringing in an Oracle based MES system, there'll be costs there. And then we would also have some, again, not necessarily super technical questions, but the look and feel of the system, depending on what level of graphics they want. If they want, just information presented that looks like Excel, that would sort of limit it in one area. Or if they want, the fancy Web 2.0 graphics with gradients and shadings and real-time animations, that would help influence that decision. And then kind of again with the integrations, we would also seek to understand any business systems that they may have in play, as far as a quality control system or a lab information management system. How we get data out of that and into the MES system would really kind of influence that. And from there, we would then look at cost. We would basically define a set of requirements or a roadmap as far as what systems are available to them, and that may filter out a couple. And then we understand cost, which is, licensing for this particular vendor is X and licensing for this other vendor is Y. But, if Y is higher, here's what you get with that. Not to pick on anybody, but this would be looking at like the cost of a process historian for some of the vendors that don't include that in their licensing cost, where you need to buy a separate historian if you want process data outside of OEE values. There's an added cost there. And then it becomes a matter of, is that cost outweighed by the benefits of that solution, or does it matter that that cost is there and we need to go to a different solution that includes some different functionality there? And that's not necessarily an easy question to answer. And typically that takes some back and forth between us and the customers to understand the best solution for their needs. But generally, we give them a couple options and then have them go talk to some of our other customers that have used that or other solutions. And honestly, we're not geared to selling a particular solution over any other. We're really focused on selling what's best for the customer and helping them understand why we think one is best. And if they don't think it's best, then that's okay. We'll certainly help them with whatever they're interested in. That's kind of a long-winded answer, but it's also a very complex question. And if you have questions about a particular comparison between vendors or what may be best for your customers or your particular situation, we're certainly happy to give our input on that. Just reach out to us at any time. We're certainly happy to help. Obviously, we're putting on this webinar, so we're not necessarily looking at it as, come buy from us. It's let's help the ecosystem and help everybody understand what's out there in the marketplace and how they can get what they need to do what they want to do better. Does anybody else have any questions? Either in the chat or in the question window here. We'll give a couple minutes in case anybody has some follow-up questions. Again, if not, you can always reach out to us. And we're going to provide a recording of this webinar, and we'll also summarize any questions that we get on Thursday's session and send all those out to you as well, so that you have all the information that was available regardless of your schedule. And otherwise, I really appreciate you taking the time to sit down with us, and we look forward to hearing from you in the future. Thank you. Okay, I think that's probably it for questions. I'm going to stop the recording and end the webinar here. Again, check us out online, or feel free to reach out any time with any questions you have. We're happy to start a discussion and answer anything you might have. Thank you.